Okay, so for number 5, you just want to remember like A1, A2, A3, A4, A5. So what they're asking you to do is look at the sums. So like the sum of 1, well, that's just 1. The sum of 2, 1 plus 1 over 4, which is going to be 1.25. S3,
I got 5/4,
which is
I
still
know is the same as that.
1.125.
Oh, so if you just divide it,
Yeah.
so okay, because I did fractions because I didn't know.
And what you could do here, like you already know what this value is, so you could just make it 1.25 or 5 over 4 plus 1 over 9. Does that make sense?
Yeah.
All right, and the same
So
thing.
do you want it divided, or can I just say 5/4?
Whatever you want, you do you.
Okay.
It doesn't matter. But that's all you're doing. Is they just want you to find the partial sums. They're not asking you to do anything else.
Okay, it just felt too easy. And
Yeah, no, I got you. And then 52 is the one we kind of were like, hey, what's going on? So 52.
Yeah. I mean, I got it. I think I got it right because I just followed the example problem we did.
Yeah.
Yeah.
But I was just trying to figure out when you like which one's A and which one's R whenever you're doing it.
So R is always the one that's raised to a power. Always,
Okay.
always. So the big thing here is just making sure that basically you're rewriting this as 7 times 1 over 5 to the n. Because 1 to the nth power is always going to be 1, and then 5 to the nth power is the one that would change. And then you already know. So like once you make that, you know that A is 7, R is 1/5. So since R is less than 1, then it converges.
Converges.
Okay. And then for 21, like, it's, okay, so it was like 1, 1.9, 2.71,
Yeah.
3.439.
Yep.
So it's not really going towards a specific number, right?
Correct.
So it's going to infinity.
Correct.
So it's diverging.
We're on 21.
Yeah.
Wait, what's 21 look like? Hey, what's 21? You're thinking about infinite. What's 21?
What's 21?
Yeah. Look at 21. Look, right on 21. Look, on 21, you have the summation of n equals 0 to infinity of 0.9 to the nth power. Yeah. What's this?
That's an N.
Yeah. But what is this? This is 0.9 to the
So that's R.
to the nth, right? So R is equal to 0.9.
I just did all that work for no reason.
So R is less than 1, so it converges.
Oh.
So I was wrong.
Okay.
Correct. You were wrong.
See, I thought that's what...
No?
Oops. Okay, so I'm going to be honest. I thought that's what we were supposed to do. And then when I was asking for Mackenzie for help, she's like, I did this. And I was like, maybe that's what we're supposed to... I don't know. I was very confused, but hey,
all good.
We got it.
Wait, so same thing for 45?
In the problem, that's how you do it.
45, same difference. R is larger than 1, so it diverges.
Awesome.
Am I going to get that wrong in the homework? Are you going to
No.
count that wrong?
No.
Okay.
That's why it's homework.
Okay, wait, I have a question.
I have an answer.
So, how do you tell when to use infinite series or geometric series?
Look, if you look at 11 through 18, right? If you have a value that's raised to a power, so like 11 and 12, those are geometric series because they're raised to a power. But 13 through 18 are all infinite series.
Okay.
Because if you raise to a power of n, you're most likely a geometric series.
So the example you gave yesterday for infinite series, I have 1 over 2 raised to n.
Oh, that's true. Hold on. In Memento. Let me scroll back. I don't disagree with what you just said.
Okay.
I think we start at 1 for that though, right? The series starts at 1. Yeah. The series starts at 1.
Okay, so
And geometric's gonna start at 0.
if that's what determines
That's
it.
yeah.
If it starts at 0, it's geometric. If it starts at 1,
Yeah, and like if you look back at the properties too, when you do geometric, you have like a designated a value and then r to the nth power. Where infinite series, that isn't the case. Now, for the example we did yesterday, you could use yeah, you could use that and say it converges. Like you could still use the series geometric series properties, because like that would be 1/2, which is less than 1, so it would converge.
okay.
Like that's one of those like loopholes where you could use it either way, but in general, if they don't have an nth power, then you're probably going to be dealing with infinite, at least in this section.
Okay.
Does that make more sense?
Yeah, and if it does have an n power, but it starts at 1, then it's infinite.
Yeah.
Okay. Sounds good.
Like you can make the argument and like use some of the same properties, but I would just consider it to be infinite and move on.
Okay.
Okay.
Sounds good.
Cool. Okay. I'm gonna split this up into 2 things.